Alright, here is quiz 6 for Math 243 solutions. What we're given is that 75% of students think there is too much information crammed into this class. I would agree. This is our population proportion. We use the letter P for it. In a random sample of 225 students, what is the probability that less than 164 of them think that there is too much information crammed into 243? Okay, 225 is my value for n. And then this 164 I can use to figure out the point that we're talking about, kind of my sample proportion, or the boundary for my sample proportion. Anyways, let's just do this in order. I'll get to that in a minute. First, shape, center, spread. Shape of this distribution is approximately normal. Why? Because it's always approximately normal. Man, this is going slow. Approximately normal. At this point in the class, we can justify why it's approximately normal. We can quote the central limit theorem and say that, or I guess the analog of the central limit theorem, that n times p times 1 minus p, maybe because n times p times 1 minus p is greater than or equal to 10. I suppose I should have checked that that's true before I just stated that it's true. See, n is 225, p is equal to 0.75, 1 minus p is equal to 0.25. When you multiply that all together, you get 42.1875. How about this? How about I do n times p times 1 minus p is equal to 42.2, which is greater than or equal to 10. Good enough. Center. The center of the distribution that I'm about to draw below with an approximately normal shape will be at 75%, which is my population proportion. And the spread is a formula for that. Hopefully you know that formula. The spread, sigma sub p hat, is equal to the square root of p times 1 minus p divided by n. So what I can do is take the square root of p, which is 0.75, times 1 minus p divided by n. Nope, n is 225. Take that square root and I get this number, 0.0289. Good enough. There's my shape, my center, and my spread, and now what I want to do is answer the question. Did you ever ask me a question? What is the probability that less than 164 of them think that there's too much information crammed into Math 243? Okay, I can figure that out. There's my distribution. It's not quite approximately normal, nor is that, but I guess that's good enough. There's my distribution that was meant to be approximately normal in the center. I'll put my center, 0.75. And then I got to figure out where 164 out of 225 shows up in this picture. Let's figure out what percentage that is first. 164 divided by 225 is 72.9%. So it should be somewhere over here, 0.729, which is equal to 164 out of 225. Wants to know what is the probability that less than this number. So it wants to know this shaded region out here, less than that point, which eventually that will fill in. And I can figure that out. My calculator has a function designed exactly to figure that out. It's the normal Cdf function. And what I will put into normal Cdf is the point I'll show you. Let's go over here to that didn't work. Let's go into here to distribution. You hit second and then variables, and then go to normal Cdf. And my left endpoint, I don't have a left endpoint, negative some big number, that'll work. My right endpoint is this value, 164 divided by 225. I guess I should be writing this here. negative 9,999, 164, 225ths. And then I put in my center, which is 0.75. And then my spread, which is the square root of 0.75. It's this number right here. Square root of 0.75 times 0.25 divided by 225. And if you put all that in, it'll give us the answer. You could be copying these numbers in, but I'm going to be as precise as I can. The square root of 0.75 times 0.25 divided by 225. And if I hit enter here, if I got everything in there right, it looks like I do, it'll give me this area, which it's telling me is 0.232, or 23.2%. So to answer the above question, I just did. This area is 23.2%. Done. All right, next part. Suppose I somehow know that the standard deviation of the length of all football games is 10. In other words, 10 is equal to sigma. Unrealistic assumption that you'd know it, but we'll pretend you do. A sample of 36, my sample size is 36, randomly chosen football games. The average length, x bar, is 180. State the shape, center, spread. Fine. Shape, center, spread. The shape is approximately normal because it's always approximately normal. The reason it's approximately normal is because, hurry up, because our value of n, which is 36, is greater than or equal to 30. The central limit theorem right there. The center of our distribution, the mu, what am I doing? It's the, I don't know mu. The center of my distribution, mu, the center of the population, mu, is unknown. I'm creating a confidence interval for it, but I do know that x bar is 180, so I'll use that as my center. And the spread I'm going to get by taking my standard deviation, sigma, and dividing that by the square root of n, which is 36. And so that's 10 over 6, which is something I should be able to do in my head, 5/3, 1.67, I think. Shape, center, spread, done. Create a 90% confidence interval. Fine. God, that's horrible. Try this again. Okay, here is my approximately normal distribution. Here is the center of it, which I said above should be 180. And what I want to do is create a 90% confidence interval. So I want to pick points, one over here and one over here. Maybe I need to switch colors so that this shaded region in here is 90%. This value right here is 0.90. Create a 90% confidence interval for the average length of all football games. Okay, I can do that. I can use Z interval. And put in all my necessary information. Z interval is under stats, tests. It's the 7th thing on the list there, Z interval. I have statistics about my data, that the standard deviation is equal to 10, the mean is equal to 180, and that n is equal to 36. And what I want to do is create a 90% confidence interval. And if you put in all that information in it, calculate, it'll give you two values. It'll give you 177.26 and 182.74. Note that I put in sigma because it asked for sigma. I didn't put in my spread here. Calculator calculates the spread all on its own. So what this is saying is I don't know mu. I don't know the average length for all football games, but I am 90% certain that that value is some number between 177.26 minutes and 182.74 minutes. So I guess that's my answer, and that is the end of this quiz.